All right, today we're going to continue our knowledge with 7.1 and 7.2, talking about exponential growth and exponential decay. But yesterday we talked about the specifics of the graphing. Today we're going to be taking our growth and decay models and applying them to real-life situations within equations. So we're going to have equations that we're going to be looking at and the real-life situations to go along with those equations. Now, first thing is our two equations. We're going to have a growth equation and a decay equation. And if you notice from those two equations, they are identical, except for the growth equation has a positive, the decay equation has a negative. The growth equation, we're going to be adding that r. The decay, we're going to be subtracting it. Now, if we go down and we read what all the letters stand for, A is the initial amount. And it says the initial amount before measuring your growth or decay. So initial means whatever you're starting with. So that's your start amount. The R is the percent increase or percent decrease per year. And that comes from the positive or the negative. It would be an increase with a growth. That's why it's a plus that rate. It would be a decrease with the decay. Hence the reason it is the minus that rate. The thing that you have to remember is right here in green. You have to write your rate as a decimal. If you don't write it as a decimal, you will never get the right answer. Okay, so writing it as a decimal, remember we have to move that decimal place over 2 positions. T is always going to be time, just like in almost any equation. And that 1 plus and minus r, we're going to call the growth and decay factors. That's going to tell us how much we're growing or how much we are decaying. Now, understanding percents and understanding these models, hopefully we all know that 108% comes from 100% plus an extra 8%. At the same time, 87% can be considered 100% minus 13%. Now, let's make sure we understand how we're going to have to write these as decimals. If I'm going to take these and write them as decimals, I have to go backwards 2 positions. So that 108% is written as 1.08. 100% would be 1.0. 8% would be 0.08, which I need to fix that, so you guys will too. 8% would be 0.08. And when you add those together, that's where you get your 1.08. 87% would be 0.87. 100% still that 1.0. 13% is 0.13. And if you were to take 1.0 minus 0.13, that is where you would get your 0.87 or your 87%. Now, when we're taking these and looking at them in comparison to growth and decay, the first one, this 108%, hopefully we recognize is a growth. That 100% is growing by 8%, hence the reason it's now 108. The second one, when we look at it, hopefully we can tell it's a decay. We are getting rid of 13%, hence the reason now it's only 87. So your growth is when you add to that 100%. Your decay is when you decrease from your 100%. You can see this written or expressed in a couple different ways. One way will be growth. Another way will be retention. If you hear the word retention, that's the same thing as growth. How much is left? So a 13% decay, so that's that 100 minus 13%, can be considered as an 87% growth or an 87% retention. And how you're going to see this in your equations is as this 0.87. So you can think of that as a decay, a 13% decay, or you can think of it as a growth. It's only growing 87%. You can think of it either way. Now, our first example, question 1. It was determined that the growth of a Midwest city increased by 9% each year since 2005 when the population of the city was 42,000. A says, write the model giving the population P of the city in 2005. So we need to write a model. Model means equation. So they're asking us for the equation. So our general equation, because of this word right here, increased, is going to be y equals a1 plus r to the power of t. Increase, so we're using that plus sign. Now, plugging in what we know to actually get our equation. The population is going to equal our starting amount. Remember, A was our starting amount. So 42,000, 1 plus our rate is 9%, but we're going to write that as a decimal, so 0.09 to a power of t. This is an equation, so you need two variables. We have our p and we have our t. It says the equation is starting in the year 2005, so when they ask us to write the equation out, make sure you have both variables. Only thing you need to do to finish it out is actually figure out this percentage in here. P equals 42,000, and when we add that together, we get 1.09 to a power of t. This is our model. This is our equation. Looking at this equation, there's two things you got to recognize. Our starting point is 42,000. And we are growing. This represents a growth of 9%, or this is 109%. So two things you should recognize by that. The second part says, what is the population of the city in 2010? Going back to what we said a second ago, this equation is for 2005. So when they ask us for the population in 2010, we need to recognize that is 5 years later. So all we have to do is put 5 years in for time, in for t. So we have the population equals 42,000, 1.09, and our time is 5 years. Type that in your calculator. Make sure you have your 5 as your power. Parentheses work just fine right here, or you can write a multiplication symbol. Type it in. And before you even write your answer, think about the fact that this is an increase. So after 5 years, I should have more than 42,000 since we are increasing in population. So when I type this in, I get a new population of 64,622. So in 2010, that would be my new population. The last part says, assuming the growth rate remains constant, what will the population be 3 years from now? That's a key word right there, 3 years from now. Well, now, hopefully we all know, is 2014. So 3 years from now would be 2017. Okay, again, remember where this equation starts from. This equation starts from 2005. So if I'm looking for 3 years from now, 2017, that means 12 years have gone by. So that is what we're plugging in this time for our time. So we have population equals 42,000, 1.09. This time our years, we have 12 years that are passing. And again, our population is increasing, so it should be greater than 42,000. And if we reference question B, this was in 2010, the 64,000. So if we're doing 2017, we should be even bigger than this 64,000. So when we type this in, we have a population of 118,132 people. So that's our first equation. That is our increase, or that is our growth. Now let's look at another one. Second equation, or second question. It was determined that the population of a Midwest city was decreased by 4% each year for the past 8 years. 8 years ago, the population of the city was 10,800. First thing, same. Write the model. We need the model for 8 years ago. The first thing I would do is understand what this means. If it is 2014, 8 years ago was when? 2006. 2014 minus 8 means 2006. So that is our date for this equation. So we're writing our equation. Keyword again up here in green, decreased. So when we're doing this one, we have y equals a1 minus r to a power of t, since we have decreased now. So we have population equals, a is our starting point. Our starting population was that 10,800. 1 minus our rate is 4%. Again, we have to write this as a decimal, so 0.04 to a power of t. Finish it off by combining that percent in there. So our population equation is 10,800. 1 minus 0.04 is 0.96 to a power of t. Now, recognize, why is this a 0.96? It's less than 100. It's less than 100 because we decreased by 4%. That's why it's a 0.96. So that's our model. Now we need to use our model for the second question. It says, what is the current population of the city? Current. Current meaning right now. Right now is 2014. Again, 8 years ago was 2006. So right now is 2014. So that is 8 years. 8 years have passed. So we take our equation. P equals 10,800. 0.96. Our time is 8. 8 years have passed. Current population would be 7,791. Next question. Assuming the trend continues, what will the population be 4 years from now? Okay, again, now is 2014. So 4 years from now, add 4 years, 2018. Now, take that again back to when this equation started. This equation started in 2006. So 2018 from 2006 gives us a total of 12 years. So the time that has passed 4 years from now would be 12 years. So population, 10,800, 0.96. Time that's passed is 12 years. We plug that in. 12 years has gone by. So again, reference what you already know. After 8 years, we went from 10,800 to 7,791. So now we're at 12 years. So when I figure this out, we should be even lower. We keep decreasing. So plug that in your calculator. You should get 6,617. Now, D says, estimate the year when the population will be around 6,300 people. Well, look at the last question. After 12 years, we were at 6,617. And we want to know, when are we about 6,300? So right now, let's just assume we're pretty darn close. If we go one more year, which would be 13 years, let's see how close we are. So 10,800, 0.96, 13 years. Plug that in. And after 13 years, you're at 6,352. So it says, when are we going to be pretty darn close, or around 6,300 people? Well, this is about as close as we can get. So after 13 years. So that's our examples for our growth and our decays, and several ways that we can use them. Now we're going to take something else into the picture. We're going to talk about compound interest. And when you think of interest, hopefully your mind thinks of money. That is where you're going to use this equation most of the time. So compound interest, we got a lot of things with this one. A equals P, parentheses, times 1 plus R over N, parentheses, to a power of N times T. Okay, I've given you all the definitions down here. A is the total. So when we're thinking about money, the total is what you get in the very end. So A is what you get in the end. P is the initial deposit. Okay, another word for initial deposit when you're talking to banks will be your principal. Your principal is what you put in. So P is what you're putting into the bank, or what you're putting into the money market, or whatever that you have. R is your interest rate still, doesn't change. And again, as you see here in green, it has to be written as a decimal. N is the number of times that it's compounded, which we'll talk about here in a second. T, still time. Okay, now N, this N is new. The number of times it's compounded, you're going to see compounded in several different ways. Okay, annually, semi-annually, quarterly, monthly, and daily are the most common. So when we think about compounded, compounded means carrying over. So I can carry over annually or semi-annually or quarterly, monthly, daily. And that's going to tell me how many times my money is gaining interest. Okay, so the more times I gain interest, the better. So daily would gain more money than annually. The more times I'm compounding, the more money I make. Now, understanding what these represent. If I only compound annually, I only compound once per year. So therefore, what's semi-annually? Semi means in half. So if you see semi-annually, I'm compounding twice in a year. Quarterly, hopefully you can guess, quarterly would mean I'm compounding 4 times in a year. Monthly, compounding 12. Daily, don't worry about leap years. Daily, we'd be compounding 365 times per year. So that N is going to change each question depending on what words you see. But this is the equation that we're going to use when we're talking about interest and we're talking about money. So our first example, question 3, it says you invest $2,000 at a local bank for 3 years. They agree to give you 6.75% interest and you will compound your account monthly. How much will you have at the end of 3 years? Okay, well, first thing, we're talking about money, and hopefully you see the key words compounded monthly. So that tells you we're using our equation A equals P 1 plus R over N to the N times T. And all we got to do is plug everything in and take our time when we're solving. Now, you invest $2,000. So that is what you are putting in. That is your P. So 2,000 is what we put in. 1 plus. R is always your rate. Rate is 6.75. Remember, we have to move this over twice when we talk about writing this as a decimal. So this is 0.0675. N, remember, is our compounds. Right here it says monthly. So we're compounding 12 times. And then I have N and T up here as a power. So N again is 12 times our time. We got 3 years going by. Now, before you try to type this in your calculator, do 2 parts to make it a little bit more simple. Figure out what the parentheses are and figure out what your power is, and then go ahead and type it in. So I have an initial amount of 2,000. So in your calculator, you're typing out this parentheses. We have 0.0675 divided by 12. Add 1 to that, and you should get 1.005625. And then figure out your outside. 12 times 3 is 36. Once you figure those 2 things out, this is a good place that you could type it into your calculator, but do not try to type it in the step before. You'll make a mistake. So here's our equation. Okay, a couple things. We're compounding interest for 3 years, so when we type this in, make sure you have a realistic answer. If you get something like $10,000, that's crazy. The bank is losing money. If you only put $2,000 in and you get $10,000 back, that's crazy. So make sure your answer makes sense. And then the second thing, make sure when you're writing out these decimals, do not round. You're talking about money in cents. If you round, your cents are going to be off. So make sure you don't round. Make sure you write this decimal all the way out. So take this, type it in your calculator if you haven't already. We put $2,000 in. After 3 years, we should have $2,447. And when you round, we're talking about money. So we have 2 decimals. So $2,447.53. Okay, let's look at another one. You deposit $1,000 in an account that pays 3.2% annual interest compounded quarterly, and you leave the money in the account for 5 years. Find the balance after those 5 years. Okay, so again, we have the same equation. I'm putting in $1,000. So A equals $1,000. 1 plus. Remember now we have R over N. My R is 3.2, so again, move this over twice. So we have 0.032. It says compounded quarterly. So my N down here is 4. Up here I have N times T. N is 4 times my time is 5. And again, take one more step before you type this in your calculator. A equals 1,000. Type in 0.032 divided by 4. Add your 1. You should get 1.008. Do your power. 4 times 5 is 20. Again, now's the place where you can type it in. 1,000 times 1.008 to a power of 20. After 5 years, our $1,000 is now $1,172.76. So we gained a little bit. If I were to ask you how much we gained, how much would you say? We put 1,000 in. So if I ask you how much we gained $172.76. So a little bit, not a lot, but we gained some interest with that money. Now, the last one's a little bit different. It says you want to have $5,000 after 3 years. Find the amount of money you have to deposit if the account pays 3.5% annual interest compounded semi-annually. So this one is backwards. So when I'm thinking of my A and my P, I have to make sure that I put the correct number in the correct place. I want $5,000 after 3 years. That's what I want. That is my A. So when I'm plugging this in, that goes in for A. The question says find the amount of money you should deposit. So I'm looking for P. So this one's backwards. So A, I want $5,000 in the end. P is what I'm looking for. How much do I have to deposit? 1 plus my rate, 3.5%. So move it over, 0.035. Compounded semi-annually. Remember, semi-annual means it's just going twice. And then rate, N compounded semi-annually, 2 times time. We said it's in 3 years. Now, first step's the same. Do your parentheses, do your power. So I have $5,000. P, when I type this part in my calculator, 0.035 divided by 2, add your 1. You get a pretty long decimal, 1.0175. 2 times 3 is 6. Now, since I'm solving for P, I'm going to go ahead and continue right here. So I have 5,000. P. Now, go ahead and type this in so I can get my number. 1.0175 to a power of 6 gives me 1.109702354. And again, we don't want to round because rounding just means we're going to be losing our pennies. So don't round. Now, how are we going to solve for P? This is P times, so how do we move this over and solve? If it's times, we have to take 5,000 and divide by this long decimal. That's going to get P by itself. So if we want 5,000 in the end, how much do we have to put in? We'll type this in your calculator if you haven't already. 5,000 divided by our decimal. We will have to put in the bank $4,505.71. So our lesson for today, growth and decay, compound interest, a lot of equations, and a lot of real life situations. You'll get your homework tomorrow in class, 7172 applications worksheet. Hopefully this video is a little better than the first. See you tomorrow.